Have you ever wondered whether Mars was once habitable? Could life have existed there? What might have happened to prevent it from continuing? Recently, after some drilling carried out by NASA's Curiosity rover, scientists found evidence of something very familiar to us, the carbon cycle. This discovery led to an exciting hypothesis. Maybe Mars really was a habitable planet in the past. And if that's true, well, NASA decided to follow this hypothesis and outlined a plan called Follow the Water. This idea had already been guiding other missions sent to the Red Planet, such as those of the Spirit, Opportunity, and Perseverance rovers. Remember, a rover is a space exploration vehicle designed to move across the surface of a planet or other celestial body. Even before these new findings, scientists already had strong evidence that Mars once had liquid water and a thicker atmosphere than it has today. And if Mars had water, could it also have had life? Did the planet, at some point in its history, offer the right conditions for life to emerge and develop? Well, to answer these questions, one essential piece of the puzzle was still missing: the carbon cycle. This process is fundamental to life, at least as we know it, because it involves the constant exchange of carbon between the biosphere, atmosphere, hydrosphere, and lithosphere. It maintains environmental balance and enables the recycling of one of the most important elements for all living beings on Earth, oxygen. But how can we know if this cycle ever existed on Mars? The first step would be to find so-called carbonate rocks, also known as limestone. These rocks are mainly composed of two minerals: calcite, calcium carbonate, and dolomite, calcium magnesium carbonate, and they are a good indicator of the presence of the carbon cycle. Though until recently, there was no clear evidence of this type of rock on Mars, but after more than 40 drillings performed by Curiosity, it became possible to conduct a more detailed investigation into the planet's composition and geological history. According to the journal Science, scientists determined that for Mars to have hosted liquid water in the past, it must have had a dense, carbon-rich atmosphere, especially rich in CO2. That's because today, Mars has extremely low atmospheric pressure, as well as very low temperatures, which makes the existence of liquid water on the surface impossible. The idea is that this atmospheric CO2 reacted with volcanic rocks, the so-called basaltic rocks, forming minerals, particularly carbonates. The problem was that previous missions did not find enough carbonates on the Martian surface to confirm this theory. It was almost as if the carbon had disappeared from Mars. This puzzled scientists. How could liquid water have existed without a significant presence of CO2? This mystery only deepened curiosity about the possibility of life on Mars. Then, in 2023, Curiosity drilled into a region called Ubajara in Gale Crater, and that's where the surprise came. Researchers identified the presence of siderite, a ferrous carbonate mineral. And it wasn't just there. In several other areas analyzed, the samples showed 5 to 10% siderite in their composition, a considerable amount of this type of mineral. That's how Curiosity finally solved the mystery of the missing carbon. The answer was siderite, but it wasn't visible. This mineral was hidden beneath layers of sulfate, which are also common on Mars. And if these sulfate layers in other regions are also hiding carbonates, that could explain where all the CO2 from Mars' ancient atmosphere went. In other words, the carbon cycle may very well have happened on Mars. Here on Earth, carbon is constantly moving, cycling through the atmosphere, oceans, soil, and living beings. Volcanoes release CO2, plants absorb it during photosynthesis, animals breathe oxygen and release CO2, and even rocks participate by absorbing and eventually releasing the gas. It's a dynamic cycle that has sustained life on Earth for millions of years. Based on the new discoveries, scientists began formulating theories on how this process worked on Mars. The most accepted hypothesis is that Martian rocks absorbed far more CO2 than they could release back into the atmosphere. As a result, the gas disappeared from the air and remained trapped underground, disrupting the carbon cycle. Analyses also revealed the presence of compounds like iron oxyhydroxides, which form when siderite dissolves in acidic water. And yes, we know that Mars had acidic water thanks to earlier discoveries by the Opportunity rover. In other words, the newest findings are fitting perfectly with the older ones. What likely happened to Mars, and what serves as a warning to us, is that at some point, its carbon cycle lost balance. The rocks began capturing more CO2 than the planet could return to the atmosphere. This caused a drastic transformation. With less CO2 in the air, the atmosphere became increasingly thin, and the water began to evaporate and vanish, until Mars became the cold, dry desert we know today. So what was the big conclusion scientists reached? Mars was indeed habitable in the past. The discovery of the carbon cycle was the missing piece in this Martian puzzle. The presence of siderite indicates that there was once an atmosphere rich in CO2, liquid water on the surface, and a less hostile climate. All this reinforces what earlier theories had already suggested. Mars had the necessary conditions for life as we know it. But that same discovery also raises a new alarm. At some point, Mars stopped being habitable, and the question that won't go away is, could the same thing happen to Earth? That's now one of the main concerns for scientists, understanding how Mars lost its habitability. Future missions already have a clearer path. We now know that siderite is hidden in regions with sulfates, so the next step is to observe those areas, focus the studies there, and collect more samples. Each new discovery can help us understand not only Mars' past, but also Earth's future. To sum it up, the Curiosity rover found siderite hidden beneath sulfate layers. This proves that at one point, Mars had a lot of CO2 in the atmosphere and liquid water, meaning the planet had its own carbon cycle. And if it had a carbon cycle, it was habitable. That's the scientists' major conclusion. And if it's true, the next step is to answer the most exciting question of all. Was there ever life on Mars? Because one thing is for a planet to be habitable, but it's another thing entirely for it to have actually harbored life. The mission to investigate that now falls to Perseverance, Curiosity's mission sibling, which is exploring Mars in search of that answer. And if it finds anything, each discovery on Mars seems to complete another chapter in a fascinating story. First, we realized that there are other planets beyond Earth, and Mars caught our attention. With advances in technology, we finally got there. Then scientists noticed dry riverbeds, which led to the hypothesis of past liquid water. That hypothesis was later confirmed with the help of Spirit and Opportunity, which collected rock samples. That confirmation came through rounded rocks found in those ancient riverbeds. But over time, it became clear that Mars' water was different from ours. It was acidic. And so came the doubt. Did Mars ever have water like ours, suitable for life? That's when Curiosity came into the picture. Since it landed on Mars in 2012, its mission has been exactly that: to search for signs of water suitable for life. And little by little, it has been revealing that yes, Mars once had ideal conditions for life to flourish. What great news! And if it's true,